In this video, we'll be looking at the equation of a circle passing through 3 points. And if you have not subscribed to this channel, kindly spend a moment and subscribe so that when we publish a new video, you are going to be the very first person to be notified. Now let's get started. So we have this example here, and it says that if 3 points P, negative 2, 2, Q, 2, 2, and R, negative 2, negative 4, lie on a circle, find the equation of the circle. So we have this, and what it means is that since you are finding for the equation of a circle, then we should quote the formula for the equation of a circle. Then we do an Adesua substitution for the given points, and then at the end we are going to have a simultaneous equation. We solve them simultaneously, and at the end we are going to have the equation of a circle. So that is the general overview of it. Now let's put it practically. So we have our solution here, and we are referring from the general form of the equation of a circle. Of the equation of a circle. And that is known to be x squared plus y squared plus 2gx plus 2fy plus c. So in any general form of the equation of a circle, we could see that there is no g, f, and c, but they represent numbers. So it means that you have to substitute the point here, P, Q, and R, one after the other, so that at the end we can solve them simultaneously and get our general form or the equation of a circle we are looking for. So we consider the points one after the other. So for point P, that is negative 2, 2. By substitution to the general form of the equation of a circle, then we know x here to be negative 2, so negative 2 all squared, and y also known to be 2, so 2 squared, plus here we have 2g, but we know x to be negative 2 plus 2f, we know y to be 2, and then c remains c, so it's equal to 0. So negative 2 squared gives us 4, and 2 squared also gives us 4, plus, so it should be minus rather, because negative 2 times 2 gives us minus. So here we should have minus 4g, and then we have plus 4f plus c, which is equal to 0. So now we have this. You can see 4 plus 4 gives us 8, and we have 4g plus 4f plus c, which is equal to 0. So transposing 8 to the right hand side gives us negative 8, kind of regrouping like terms. So here minus 4g plus 4f plus c, which is equal to minus 8. So we can call this equation as equation 1. And then we focus on the other points. So we divide our board nicely as this, and we continue. So continue, that is the coordinate Q. So for Q, that is 2, 2. By substitution to the general form, so we have 2 squared here plus another 2 squared plus 2g. We know x to be 2, so we substitute, plus 2f of 2, and then plus of c, which is equal to 0. So here we know 2 squared to be the same thing as 4, and here we have 4 plus 4g, and then we also have 4f plus c, which is equal to 0. So at the end here we have 8 plus 4g, and then we have plus 4f plus c, which is equal to 0. So henceforth, by transposing 8 to the right hand side, gives us 4g plus 4f plus c, which is equal to minus of 8. Now let's call this as equation 2. So once we have this, then we also focus on the next coordinates. That is 4 giving us negative 2, negative of 4. Once there are negative in the coordinate, then we should be very careful when we are multiplying by the other terms too. So by substitution, we have minus 2 all squared plus, here gives us minus 4 all squared, and then the plus of 2g, but x here is minus 2, and then plus of 2f, y here is minus 4, plus c, giving us 0. So once we have this, you can see that minus 2 squared is the same thing as 4, and then minus 4 squared gives us 16, but 2 and negative 2 gives us negative of 4g. And then here we can see that we are going to have negative of 8f. So negative 8f. So we'll bring our c, that is plus of c, which is equal to 0. So 4 plus 16 gives us 20. And minus 4g here, minus 8f plus c, which is equal to 0. So transposing 20 to the right hand side gives us minus 4g minus 8f plus c, giving us minus of 20. So we can call this as equation 3. So we have equation 1, equation 2, and equation 3. Now what we are going to do here is that we are going to solve them simultaneously. Now with the simultaneous equation, remember that there are two types, either by elimination or by substitution. So to make it simple and short, we are going to focus elimination method by solving them simultaneously. So by the method of elimination, then we are going to first consider equation 1 and 2 to solve them simultaneously. So considering equation 1 and 2, now let's write here considering equation 1 and that of equation 2. So if you are considering equation 1 and 2, then we can see that when we subtract equation 2 from 1, we can see that some of the variables are going to be eliminated. So here we see that equation 1, then subtracted that of 2. So it means equation 1 minus 2, then we are going to get some of the variables here eliminated. So that becomes, so equation 1 is known to be minus 4g, and then we have plus 4f followed by c, giving us minus of 8. And we know equation 2 to be 4g plus 4f plus c, giving us minus of 8. So here, since we are seeing equation 1 minus equation 2, the minus here is affecting equation 2. So we bring the minus here, then we find our solution. So here we can see that minus 4g minus 4g gives us minus of 8g. So we have minus of 8g here. And the next one, we can see that 4f minus 4f give us 0. And here we can also see that c minus c gives us 0. So here we can see that minus 8 minus minus 8 also gives us 0. So here we can see that minus 8g is equal to 0. So what we are going to do here is that we are going to divide both sides by the coefficient of g. That gives us, so thus we have divided by minus 8 divided by minus 8. So beautifully we can see that this minus 8 will cancel that one, and 0 out of minus 8 we know is going to be 0. So we have our g value here to be 0. So that is that. Now it means that we also have to find that of f and c. So first, to find f and c, we can also consider equation 2 and 3, just like we considered equation 1 and 2. So here we write considering. So that is we considering equation 2 and that of equation 3, then means that we are going to subtract equation 3 from 2. So that is equation of 2 minus the equation of 3. So we know equation 2 to be the same thing as 4g plus 4f plus c is equal to minus 8. So write it as such. So here we have 4G plus 4F and then plus C, which is equal to minus 8. And here you also have equation 3. And from what we said is minus 4G minus 8F plus C is equal to minus 20. So we write it here. That is minus 4G and then minus 8F plus C is equal to minus of 20. So since we are subtracting, then the subtraction sign affects that of equation 3. So we find the solution as such. So 4G minus 4G, we know it's going to be 8G. So that gives us 8G. And here we can see that 4F minus 4F gives us the plus of 12F. And here we can see that C minus C gives us 0, which is equal to, here we can see that minus 8 minus 20 gives us 12. So we have this. Now, once we have this, it means that we can equally substitute the value of G into this, and then we can get the value of F easily. So we refer, but we know that G is equal to 0. So when we substitute, then we are going to have here as, when we substitute, then we are going to have, that is 8 multiplied by 0 plus 12 of F, which is equal to 12. So we know 8 by 0 gives us 0. What's left here is 12F, which is equal to 12. Now here we divide here by 12, we divide there by 12. So we can see that our F value here is equal to 1. So it means that our F here is equal to 1. So now we have F and then G. Now the next variable left here is C. So we just have to substitute the value of G and F into either equation 1, 2, or 3, because they are the equations that contains the 3 variables. So since we are going to substitute into equation 1, 2, and 3, then we can choose any of them. So preferably we are choosing equation 1. Now we can state here, substituting G is equal to 0 and F is equal to 1 into equation 1. We are doing that to find C. So into equation 1, then remember that our equation 1 was given as minus 4G, I believe, remember, plus 4F, and then plus C, which is equal to minus 8. So if you know that of C and F, then we can substitute to find our C value. So here minus 4 multiplied by 0 plus 4 multiplied by 1 plus C, which is equal to minus of 8. Now minus 4 times 0 gives us 0 and 4 times 1 gives us 4. You have our plus C here, minus 8. So once we have this, then means that C makes it the subject by transposing 4 to the right hand side. And here we can see that our C value here is equal to negative of 12. And this becomes the value of C. So we can see that G is equal to 0, F is equal to 1, and C is equal to negative 12. So what we are going to do is that we are going to substitute these values into the general form of the equation of a circle. Remember. So we write again by substituting G is equal to 0, F is equal to 1, and C is equal to negative 12 into the general form of the equation of a circle. Then that becomes, now before that, let's write the general form of the equation of a circle. We said is the same thing as x squared plus y squared plus 2gx plus 2fy plus c, which is equal to 0. So once we have g, f, and c, then we do a necessary substitution. So it means that we maintain our x squared plus our y squared plus 2. Now our g value here is 0, so we bring our x plus 2, and then our f value here is 1. We have our y here, and then c is going to be negative 12, which means that we have x squared here plus y squared, and 0 multiplied by 2 times, so it gives us 0. So it means there is no x value here, and what is left here is y. So 2 times 1 gives us 2, multiplied by y gives us 2y, and we have minus 12 is equal to 0. So therefore, the equation of a circle passing through the points P, negative 2, 2, and Q, 2, 2, and then the R, negative 2, negative 4, is giving us x squared plus y squared plus 2y minus 12, which is equal to 0. So this is how we find the equation of a circle passing through these 2 points. Now, thank you for enjoying this video, and we appreciate your presence. So thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is BakoMaths, thinking beyond infinity.